Okay, so rational expressions, like I said before, this is basically polynomials and fractions smushed together in a sandwich. So that's basically what it is, okay? So if you recall back to Math 10C, we talked about a rational number, and that was basically any number that could be written as a fraction, okay? Okay. So like 7, is 7 a rational number? Yeah, because you can put a 1 underneath and it's a fraction. Is pi a rational number? No, because what's different about pi? Good. So if you take a look at the decimal, if the decimal like stops or repeats, it's like a rational. If it does not do that, if it just goes on randomly forever, kind of like root 2, that decimal goes on randomly forever, root 2 is not rational. So we're doing rational expressions, okay? And you can see some examples here. All right. Looks like my iPad turned on, so we'll switch over. I wonder if the pencil's dead. Let me just check. Yeah, we'll just go old school. Okay. So in this unit, we're going to learn how to add, subtract, multiply, and divide. Okay, so like I said, anything you could do with a fraction, we're going to do with polynomials. Okay, and basically this is all the stuff from polynomials that you need to know how to do. So basically, if you can't factor polynomials, this unit is really going to be a disaster. So if you struggled with the factoring unit, you got to get good at it. Okay, so that's what this little section is. And I don't want to do the exploration. I don't want to do the exploration. We're just going to talk about it. Okay. So class example 1. So yeah, we're going to do 2 lessons today. So if you take a look at class example 1, what do you see? Bunch of polynomials in fractions, right? In part B, it's already factored. In part D, it's not. And if you look at part A, it's all monomials, and if you look at the rest of them, there's binomials and trinomials, okay? So put monomial here, and put binomial here, and even trinomial here. So for the most part, we're going to live with binomials, trinomials. We're going to be doing a bunch of factoring, and that's what you're going to be used to. From time to time, you're going to be seeing monomials. These are the easiest to do, and it's review of Math 10, exponent laws. Okay, so let's take a look at this. 12 over 2, well, that's just 6, right? 12 divided by 2. What if it was 2 over 12? 1 over 6, right? Okay. Now, let's take a look at the x's. x2 over x. And think of it like as a battle. Like, you ever play Risk? You guys ever play Risk? And you roll the dice? Yeah, so who would win this battle? 2 x's versus 1 x. Yeah, the 2 x's up top will win. Okay, so this would be like 6 over 1. And then you got x times x over x. So 1x left over in the top, right? So let's just clean this up a little bit. And like, even if you just like do it on here, this is so easy. 12 divided by 2, well, that's 6 over 1. Do you need the 1 in the bottom? It's just a placeholder, so you don't need the 1. And then x2 over x. You can also think of it like this. It's just 2 minus 1 in the power. 2 minus 1 is 1, so this is just 6x. This is the answer, 6x. But I skipped a whole bunch of stuff, a bunch of investigation. So there's probably some things valuable in there. And what was valuable is this. Non-permissible values. So let's just do a little bubble over here. And let's call this NPV. Think of it like as Call of Duty or something. NPVs. Doesn't this kind of sound like that? Yeah. So non-permissible. So what's a non-permissible value? What does that mean? Non-permissible. Is it allowed or not allowed? Not allowed. And a value is just a number. So it's just a number that's not allowed. And what's the one thing in math that you cannot do? You cannot divide by 0. And everybody knows this. And here we're going to see it in action. So do you remember the zero product rule from factoring? Like, let's take a look at this bottom here. What if that was equal to 0? What values of A would make that 0? -7 and -1. So those values are non-permissible for B. Okay, so let's just put a little definition here for non-permissible values. The values which make the denominator equal to 0. Okay, and the value or the values could be plural, could be singular. There might not even be one. Like for example, x over 5. I just jot this down on the whiteboard, x over 5. Is the denominator ever 0 or is it always 5? Yeah, it's always 5. So this is always going to be permissible. All values are permissible. But for this one here, there's an x in the bottom. So for which value is this x non-permissible? Yeah, so you just say x can't be 0. Okay, so you'd write it like this. This rational expression equals 6x as long as x isn't 0. Okay, let's see if we can find one in the assignment. That's monomials only. Number 2 in the assignment. I'll just clear this. Hopefully that's okay. Let's do number 2 in the assignment. You guys okay with that? Okay, so like in your calculator, even if you suck at fractions, you can use this. So go 4 divided by 16, math fraction. It does the work for you. Now if you're more into doing things on your own, you can see that 4 and 16 both have a common factor. What is it? 4. They both divide by 4, so you get 1 over 4. But if you wanted to use your calculator, that's cool too. Math fraction, 4 divided by 16 math fraction. And now look at you got AB over A. So the A's cancel, right? And you just have B left over. Okay, and this looks really weird, like, so just make it a little bit cuter. B over 4. Yep. Put a little comma, and then you can say, okay, which values are going to make this expression non-permissible? So look at the denominator only. What value makes the denominator 0? Because you can't divide by 0. Yeah, so you'd say 16a equals 0. Well, divide by 16, well, it has to be 0, right? So you put a little comma after your answer, a not allowed to be 0. And this is how you express it. So the initial expression, the first thing we were working with, it's simplified to b over 4, comma, as long as a is not 0, you're good. This is going to be true all the time. As long as a is not 0, you're good. Make sense? Any questions? So that's sort of math 10-ish style, math 10. And those of you thinking about going to 30-2, there's a whole unit on this. You're going to redo it again. So that's very nice. You can like score 100% on a unit. So that's very nice. This unit repeats in math 30-2. Okay, so back up to the class example 1. Let's try part B. Now what do you notice about part B that's already factored? So when we go to cancel, I mean, you need to cancel out objects that are on the top and the bottom that are identical. Everybody okay with that? Final answer, a minus 6 over a plus 7. You can put the brackets if you want. Put a little comma. So for which values is the denominator 0? A cannot be -7 and -1. Any questions about that? Good. It seems pretty straightforward, and it's skills that we've already done before. Let's jump into the next one. So in the top, you can't do anything to y plus 4, but in the bottom, we can factor that using inspection. Why inspection? Because the trinomial lead coefficient is 1. Good. There's a little 1 there. So when you open up the two brackets to factor it, I bet there's a y plus 4 in there. Just probably. Right? Now, what multiplies to 20? Negative, and adds to -1. I'm assuming it's 5 and 4, because they have a separation of 1. Which one's negative? The bigger one, right? To make the -1. So negative, positive, y and y. Which ones are going to cancel? The y plus 4 term cancels. Now, some people say, well, there's nothing left in the top. It's gone. So put the placeholder 1. Good. So you go 1 over y minus 5. The bracket is optional. Comma. What values are going to make this expression non-permissible? Good. So positive 5 and I don't know why I did that. Positive 5 and -4 are not permissible values. Even though it got canceled, it's not there anymore, you still have to put it. Okay? Make note of that, please. Even though it cancels, it stays. And the next one, in the top, use inspection. In the bottom, use... Good. Anybody else? What to do in the bottom? He said it quietly. Anybody else? Over here? Okay, good. What is it? X plus 7 and x minus 7. Good. Just because of 49 and 1. Okay, and then up in the top you have 28, and I'm assuming you're probably going to have something with 7, right? Probably. Just like being test smart. So x plus 7, and then to get to 28 you'd have to have a... Good. Now the x plus 7's gone. You just have x plus 4 over x minus 7. This is the simplified version. This is as low as it'll go. And do not do this. That's very bad. You cannot do that. And some students, if they're really lost, if they haven't done their homework, they will do that. They think that that's okay. Why is that not okay? It has to be factored perfectly. Like it has to be factored like up above here. You can only cancel when it's multiplying. Okay, comma x is not allowed to be. Okay, good, plus or minus 7. Okay, so I'll let you guys try for a bit, and then we'll do lesson 2 in like 15 minutes. Okay, lesson 2. So similar stuff, and it's all similar stuff. So you're going to want to reduce to lowest terms. What's another word for reduce to lowest terms in one word? Okay, and then what's another word for restrictions on the variable? Say it. Non-permissible value, which means it's not allowed. Okay, cool. In the top, do you see a monomial? No. A binomial. So you automatically think, I probably got to factor this. Okay? So it's not like B. B we're used to with like trinomials and factoring. So what's up with A? Good. So what's the GCF in the top? T. Take it out, you get 4t squared minus 9. All over. Take out another t, and you get t, 2t minus 3. I'm just going to erase that because it looks really ridiculous. 2t. So what's going to happen with this t? Okay, somebody spotting something in the top? Okay, very nice, Daoud. Always check for more factoring. That's part of the factoring unit. And you remember that flow chart? Right at the bottom it said always check for more. So in the top, you have a difference of squares. Square root 4, square root 9, square root t. You see it here, one's plus, one's minus, all over 2t minus 3. And you see more canceling, right? So that's gone. So all together, you're just, this is all you are. Except what? Good. You can only be equal to this expression, comma, as long as t is not 3 over 2. That's coming from this guy, right? So if you forget this stuff, I'm thinking about Jolene here. Cover up the 2. What would it be? What's opposite of negative 3? And then cancel the 2. So 3/2. And then there's one more. Very nice, Jordan. Where'd you get that from? This t right here, right? A monomial with the variable. Okay? Let's go to the next one. The next one, that looks challenging. Why? Because the coefficient on the x squared is not 1. So that's when you kind of like, you know, you only got so much space on this paper, right? So then I would be like, okay, off to the side. And I would just do some busy work. Like if you're on a test, you just scratch out some factors on the side. So how are you going to get to, what's the AC value? 6 negative and B is 5. Okay, so how's it going to factor? What two work here? 6 and 1? Which one's negative? Because the bigger one has to be positive. Okay, so we got a 2x squared plus 6x minus an x and minus a 3. So just doing this on the side. So if you're watching the video, you sorry, I just had a little mental breakdown there. Okay, so GCF pairs. What's coming out of the first two? 2x, and you get x plus 3. See how you got a plus plus, here's a minus minus? Take out negative 1. So this guy's going to factor to the top trinomial factors to 2x minus 1 and x plus 3. Okay, so we had to factor this all over. Do the same thing on the bottom one. So what's this one going to be? This time the AC value is negative 2 and B is 1. So 2 and 1 has to be, right? Which one's negative? Good, okay. So 2x squared plus 2x minus x minus 1. Similar. You get a 2x comes out, you get an x plus 1. Take out a negative 1, you got an x plus 1. So we got a 2x minus 1 and x plus 1. So what's canceling this time? Okay, so final answer, x plus 3 over x plus 1, comma, x is not allowed to be. Very nice. Hello, Mr. Wong. Good. Someone else ate a salad, I saw it. Protractors? Interlock? No. All I have is this. Are you talking about like Cuba links? We don't have those. Maybe Miss Pites. No problem. Okay. Again, back to the whiteboard. The top one's easy, right? What's it going to be? Top one's easy. Actually, they're both easy. We'll find out in a second why. So top one, what is it? Well, what multiplies to 8? 2 and 4. Okay, which one's negative? Negative 2 and a positive 4? Okay, beautiful. Now, with the bottom one, you see the coefficient is 1, right? So it's the same, right? A2, A2. Like there's only one way to make 1A4. Okay, and you can't have like A3 and A1 because then like the middle terms would be ridiculous. The middle terms have to be A2s, right? So these are A2s. Now what goes to 64 and 20? 16 and 4? You are fast. Now which one's negative? Are they both negative? And now what do you see here? Can I do it again? Can I do more? On both of them? Yeah, it's crazy, right? Okay, so a minus 2, a plus 4. And I'm just going to erase this other stuff. Let's get it out of the way. And we're going to have how many? So for the 16, a minus 4, a plus 4. And for the 4, very nice. Now cancel train. Hop on it. Whoop, whoop, whoop. Hop on that cancel train. The a minus 2s are gone. And she's saying the a plus 4s are gone. So is the numerator 0? What? No, the numerator is 1. Good, that's the placeholder, right? So I'm just going to go 1 over. Thank you. A minus 4 and a plus 2. Okay. Restrictions or conditions. What are they? NPVs are? There's lots. How many? So A is not allowed to be plus or minus 4 and plus or minus. Okay, very nice. It's a little bit of a different class when there's 10 less people, eh? Yeah, I noticed that when I got my stack of tests on Monday morning. Bum, bum, bum. Did you have a good weekend? Yeah. Were you in the building? With the conference? I had work. Oh, too bad. Okay, let's go to class example 2. Class example 2, I'm just going to give it away because that's the kind of guy I am. What does that say? Negative trick. N-E-G, negative trick. You with us, Rafi? Rafi's checking out the latest cricket scores. I know he is. He loves cricket. Jordan? Sure. Yeah, you don't need a calculator. Yeah. All right, I'm going to pretend I didn't hear that. Okay, stay focused. We have a C minus 4. Can we do anything with that? And then with the negative trick, what is the negative trick? Do you remember it? If the lead, good, if the lead coefficient is negative, factor out negative 1. So what are you going to take out of 4 minus C? And you get negative 4 plus C. But that just looks weird. Yeah, you want to get good at this. You want to factor out the negative and reorder all in the same step. And you don't have to put negative 1, just put a negative. And now what do you see? Yeah, this is going to cancel. So you're left with 1 over negative 1, which is just negative 1. So no matter what value of C you pick, what do you get? Let's try a value. Let's try 6. Put in a 6. What do you get? 6 minus 4 divided by 4 minus 6. So it's 2 divided by negative 2, which is negative 1. So is that always going to work? Always? When doesn't it work? Oh, very nice. So what's the non-permissible? So make sure you put that little condition. Negative 1, comma, as long as C is not... What? Positive pho? That's like Vietnamese takeout? Positive pho. Let's go for pho? That would be amazing. Vietnamese soup. Not like, not your usual noodle soup. Okay, we still have about, what, 25 minutes? How many more class examples are there? Okay, well, let's get motoring. Take out a 2 and 2p squared. Good, because 2, right? The lowest is 2. What do you get when you take out 2p squared? Lovely. All over. Take out a... Oh, no. You disappoint me, everybody. Thank you. Why? If the lead coefficient is negative. Okay. So take out negative 8. And you get... And you want to reorder all in one step because you're slick like that, right? Positive p minus 2. And now you see it lining up beautifully. If you just took out 8, it's not beautiful. If you took out negative 8 and didn't reorder, it's not beautiful. Scratch out the beautiful because... Oh, you want to make it look cute? Okay. Before we make it cute, like let's just figure, what's 2 divided by 8? Don't say 4. Yeah, good. 1 over 4. Because bigger number, right, in the bottom? Okay, so how is this going to clean up? P squared over 4. Or is there a negative somewhere? Is it okay if it goes here? Oh! We need the undo. There's no undo? Turn back time. Where's undo? Oh my gosh. Oh my gosh. There was a p squared here and a 4. I need to make a smaller eraser. Sorry, you guys. Oh, that's better. But now I'm going to lose it as soon as I... Because I want to show you. Like, does it matter if the negative's down there? As long as it's in the top or the bottom, right? Is there a nicer, cuter spot for it? Right in the middle. Good. So, like, right there. Okay? And conditions. P is not allowed to be, back to what we had there. Was it like this? Yeah. So P is not allowed to be 2 and 0. 0. 0. Not allowed, right? Don't put the 0 there, right? Don't make mistakes, right? Okay, obviously I did that on purpose for effect, right? Yeah, because sometimes, right, Shaq? Sometimes people think, oh, well, there's a number there, so just put 0 as well. Yeah, don't do that. Don't do that. Okay, let's go quickly. Now, what are we taking? Oh, that's obviously difference between two squares. So, do we want to reorder it first? Well, what if we didn't? Let's just go 1 minus 2x and 1 plus 2x. Let's just, I think most people would probably just do that. Probably. Now, the thing in the bottom, oh my gosh. Quickly, like on the side of your paper, what are we doing here? Okay, so AC is negative 24, B is negative 5. What two are going to work there? 8 and 3? 8 and 3. Which one's negative? It can't be both. Negative 8. Okay. Okay, so 6x squared, negative 8x, plus a 3x, minus a 4. GCF? 2x, and you get a 3x minus 4. It's already 3x minus 4 over there, so just take out a plus 1. Okay, so I got it now. I think. One of them was 3x minus 4, and the other one was 2x plus 1. Was it 2x plus 1? Yeah, it is. Okay. Now, do you see anything canceling? Yeah, we got lucky. We didn't have to factor out any negatives. We got lucky. So sometimes you'll see that you'll have the identical thing up top and bottom, but they just got different signs. Like, what if you had this? 1 plus 2x all over negative 1, negative 2x. Those are like the same thing, right? So you would have to factor out a negative and then cancel. But we didn't have to do that. We ended up getting lucky. So 1 minus 2x over 3x minus 4, comma, x is not allowed to be negative half from this one, right? And 4/3. Okay, you guys are rocking. How you doing back there? You hate factoring. Surviving? Okay. Yeah, Ethan hates factoring. Okay, so what is this garbage? You know, I say garbage because these questions are almost, especially with this workbook, I really like the workbook, but they often will just give like, it's always rectangles and polynomials. There is a deep connection there, so don't think that like, and you go out in your science community or like, and people are solving polynomials and rectangles in real life. Like, there's just like a theoretical connection between rectangles and polynomials. That's all this is. Like, so please don't think that there's like a real application to this. It's just deeply theoretical. When you factor this, you get two terms. It's length and width. That's all it is. Okay, the rectangle, right? Like algebra tiles, you make the rectangle. Okay, so what do we got here? 12a squared plus a 25a and a minus 7. Did they tell us one of the... Okay, so this is really easy. The length, or yeah, is 3a plus 7. So what's going to be the width? Now think. What's going to go in these blanks? How are you going to get 12? You do the FOIL 3 times. I know you guys do this on the test. I watch it. You guys work backwards on the test all the time. You look at the A, B, C, D's and you work backwards, right? This is 4a. Has to be, right? And then how are you going to make negative 7? On the last expression, you're going to have to do that one times that one, so it's got to be minus 1. Like negative 7, right? And then just double check. So we got the 12a squared, and then 7 and 4 is going to make 28, and then you're going to minus 3, so you get the 25. Good. And again, this is area equals length times width, right? Okay, if the perimeter is 54, what's the formula for perimeter for a rectangle? Rectangle has how many lengths? Good, 2 lengths and 2 widths. Okay, so 54 equals 2 lengths. We're saying length is this one, 3a plus 7, and 2 widths, 2 of those guys. Okay, I'm just going to go into part C here. Hopefully that's okay with you. I'll start writing smaller so it'll fit. What do we got in the first one? 6a and 14. What do we got in the second one? 8a and negative 2. Okay, put the a's together. You got 14 of them. Put the numbers together. You got 12. You guys okay with that? How to solve this basic linear equation? Minus 12 minus 12, what do you get? 42. 14 groups of what is 42? 14 groups of 3, 4, what is it? 3? Okay, A is 3. Okay, so we found out the value of A. That's what they wanted. Now it says the field has to be treated with fertilizer at a cost of $2.40 per square meter. Calculate the cost of the treatment. No, Very easy. It's $2.40 for every square meter. So what do you need to find? The area. So we know that A is 3. So punch it into the factored form. It's a little bit easier. 3 times 3 plus 7 times 4 times 3 minus 1. What do you got here? 9 plus 7 is 16. 12 times, or 12 minus 1 is 11. 160 plus 16, 176 square meters. How did I get 176 so fast? I did 16 times 10 and then added one more group. Okay, so if it's 176 square meters and every single square meter is 240, what do you do with this? Times by 240 for every meter square. The meter squares cancel. You get dollars, so some $400 or something, 400 and something. $422.4. Who talks like that? $422.40. Good. Someone asked me why this is flat. I figured it out. Is there more? Or are we done?
There's one more.
No, there's not. There's 3 questions in it? Well, we're doing it. 'Cause oh, these are quick, right? Just simplify, where possible. Oh, well, for the first one, that's just this, and then that's this, and make my own math rules up. No, you can't do that. You can't do that, right? That's crazy talk. Never, ever do that. Can I do anything with that? That's not going to simplify it. Okay, so do you notice that x and x are the same? Do you notice that y and y are different? There's nothing you can do. If there was a negative here, then you could factor out a negative, because then you would end up with the same. But because one of them's the same and one of them's different, you can't do anything with this. This is as simple as it gets. But you can state the NPV, so we need this to happen, right? The denominator is not allowed to be 0, so therefore x cannot be. A little bit trickier because there's no numbers. But as long as x and y are not the same thing, you're good. Like, what if x and y were both 5? You'd have 10 over 0. Good. Okay, this one in the top, you can't do nothing. In the bottom, though, difference 2 squares. You have an x minus 5y and an x plus 5y. What's going to cancel is the positive version. So you're just left with 1 over x minus 5y, comma, x is not allowed to be, and this is a little bit crazy. There's y's in there, right? So if it's crazy, you can always just solve it longhand. So let's solve it longhand. X minus 5y is not allowed to be 0. So bring one of the terms over. I'd probably move the negative over. X is not allowed to be 5y. Okay? And I don't think there's anything else to it. And if you did it with the other one, you'd get a negative version, right? So x is not allowed to be plus or minus 5y. So basically, if x and y differ by a factor of 5, like if x was 2, or if y was 2 and x was 10, or negative 10, it's not going to work. You okay with the plus or minus? Because I would just do it with 2 of them. And now over here, these are very challenging in terms of their difficulty for this concept. This is as hard as it gets for this concept. Can I do anything with the top? Not really. I'm just going to write it out though, just in case. In the bottom, what do we have? What could I take out of the bottom? 3. And then after I take out 3, what do I have now? It's a binomial with subtraction. Hint, hint, hint. So this is, if it's a binomial with subtraction, you have to think difference of 2 squares. Okay, so how is that going to factor? X squared minus y squared, x squared plus y squared. Am I done? Okay, let's do it. So this term with the minus, it's going to give me 2 more, right? And the term with the plus, can I do anything with that? No. So the x plus y's, only one of them disappears. And that's why I wrote out the numerator with 2, so you can see that only one of them disappears, not the whole thing, right? Finish this off. 6 x plus y all over 3 x minus y x squared plus y squared. And then the non-permissibles. The non-permissibles look easy. Even though they look crazy, they look easy. What is it? As long as x does not equal, no. X is not allowed to equal y or negative y or both. Both. X cannot be plus or minus y. So think about it. What if x and y were both 5? 5 minus 5, the whole thing's 0, so that's not cool. What if x was 5 and y was negative 5? Then this one doesn't work, right? So as long as x is not plus or minus y, you're good. And again, the last class example 4, that is as hard as it gets. Okay? So in general, if you can handle, I'll just look at my key. For lesson 2, I would say all of 1 and 2, I would go up to 5. 1 to 5. Challenge yourself with 6. Okay? If you can do 1 to 5, I would be ecstatic. Always do more, always if you want to challenge yourself. Yeah, lesson 2, 1 to 5. But you should be challenging yourself, Jacqueline. Go to 6. So we did 2 lessons today for 2 reasons. A, we're running out of time in school, and B, it's all the same stuff. Just different difficulty.